Welcome everyone. Let's look at some derivative examples. Figure out if f(x), a piecewise function, is differentiable at 2. What was our condition? If f derivative a exists, this limit should exist, right? Fx minus fa over x minus a. A is clearly our point. In this example, a is 2, then we will check the limit fx minus f2 over x minus 2 as x approaches to 2. Talk about the limit, we need to check it from the left and the right. Let's check this limit from the right first, over x minus 2. When x is greater than 2, my function is 4 minus x. Limit x approach to 2 from the right. 4 minus x minus for f2, x is equal to 2, which is 2 over x minus a. This part is equal to 2 minus x. So this limit is negative 1. This is our first limit. Now let's check the limit from the left side this time. Fx minus f2 over x minus 2. I am lesser than 2 this time, so I'm going to use the x. Limit x approaches to 2 from the left, x minus 2 over x minus 2, which is equal to 1. Since these limits are not equal to each other, we will say we cannot differentiate this function at 2. F0 is given to us, a limit is given to us, gx is given to us as a multiplication of a term. The other term's a function is given. What is derivative of gx at 0? Alright, it looks kind of confusing. Where should we start? Since it's asking the derivative of gx, let's start with differentiating this function. G derivative x as multiplication, here, two functions multiplied, so the multiplication rule, differentiating the first term multiplied with the other term, plus, now I differentiate the second term and multiply it with the first term, 2x plus 3. So if I write 0 for x, I'm gonna get something. Should we do it? Let's do it. G derivative 0. 2 times 0 plus 2 multiplied with f0, which is 5 given to us, plus f derivative 0, which is something that is not given to us, multiplied with 0 squared plus 0 plus 3. From here, what do I get? This part is 0, 2f0, 2 times 5, because f0 is 5, plus f derivative 0 multiplied with 3. So 10 plus 3 f derivative 0. The question is, what is f derivative 0? To find f derivative 0, of course, I need to use this part somehow. Let's see what can we change, or what can we do. Limit fx minus 5 over x as x approaches 0. My definition for derivative was x approaches to a, fx minus fa over x minus a. This should already tell you some things, right? Because if I subtract 0, I will not change anything, so I subtract 0, and 5 is equal to f0, which clearly means that this limit is equal to fx minus f0 over x minus 0, which is f derivative 0, is also equal to 5. So I found my f derivative 0, which is equal to 5. 10 plus 3 times 5, which is 25, is my answer. Differentiate the following functions. First one is a simple example. If fx is x to the nth power, f derivative x will be n times x to the n minus 1. F derivative x, 3x squared minus 3. I just use the rule here, of course. And a constant rule tells us the derivative of 5 is 0. F derivative x again, two terms multiplied, so we need to use the multiplication rule. Differentiate the first term, which is 1, no need to write it. X squared minus 1 cubed. Now plus I differentiate the second term, but I'm seeing a composite function, so I need to start from the outside of it. 3 is the power here, so 3 multiplied x squared minus 1 subtract 1 from the power, and now multiply this with the derivative of inside of it, 2x, and multiplying with the first term. Let's multiply the terms here. What do we get? 366 times x squared multiplied with x squared minus 1 squared. I will leave it like this. You can do more algebra if you want. Ft is given to us. This time we are differentiating with respect to the t, not to x. F derivative t, division of two terms, differentiate the numerator, which is 4t, multiplied with the denominator, t plus 5, subtract derivative of denominator, which is 1. So I will write the numerator. This is over t plus 5 squared. You can do some algebra again, but I'm gonna leave it like this because that's not the point of this video. Fx is given to us. We have a cube root this time. We cannot differentiate in this form, but what can I do is I can write this as 1 plus x squared to the power of 1 over 3. Now I can differentiate this because now I have a composite form. So 1 over 3 is my coefficient here, 1 plus x squared. Subtract 1 from the power, 1 over 3 minus 3 over 3, negative 2 over 3. Now multiply this with the derivative of inside, 2x, and that's it. Again, differentiate the followings. What can we do? Let's start with playing with the form a little bit. No matter what, it will be a long solution probably, but alright. Cosine to the 5th power here, and this is over 5. I'm multiplying it. Minus cosine cubed x over 3. Differentiating this. Now we can differentiate. By the coefficient rule, I can leave the 1 over 5 and 1 over 3 out. I will leave it like this. Now, again, I have cosine x to the power of 5, so I start with 5 times cosine 4th power. I subtract 1 from the power, multiplied with now inside of this, which is negative sine x, minus, we need to close the parentheses. Let's leave the 1 over 3 out again. Cosine cubed x, 3 times cosine squared x, times, inside of it now, minus sine x, negative sine x. Let's see, 1, negative 5 cancels the 5 out. Cosine to the 4th power x multiplied with sine x, and 3's cancel each other as well. Minus, there's a minus here, so this will be a plus. Cosine squared x multiplied with sine x. We can leave it like this, I guess. I mean, under the sine x parentheses, cosine squared x minus cosine. It doesn't really matter. Let's just leave it like this. Another example. Oh, okay. I did not solve these before the video. I just got these problems from the textbook, but now I'm kind of regretting this. Okay. So 10 squared x minus 1, 10 to the 4th power x. Can we do something? 1 plus 10 squared x is equal to secant squared x. I mean, we can get 1 from here, but it doesn't look like it will help much. Okay, then let's start with multiplying the terms again. Oh my god. 10 to the 6th power x plus 10 times 10 to the 4th power x plus 10 squared x minus 10x to the 4th power minus tan squared x minus 1. This is all over 3 tan cubed x. Did they show mercy to us while writing this problem? It looks like they did not. Am I? Yeah, no matter what, this will be a long problem. And I don't want to go back from it now. 1 over 3 multiplied with tan cubed x plus tan multiplied with tan x. I'm trying to simplify some terms, and I forgot the 3 here already. Yeah, we need to be careful. Tan 1 over 3 tan x from here minus 10x over 3. What is this? Minus 10 over 3 10x cubed x. What is this? Yeah, I don't really want to differentiate all of this, but I don't think there's a faster method for us to use. Maybe a substitution? Probably not, right? Yeah, I don't see it. Yeah, it looks like there's no end. I don't really want to make a mistake, but I mean, if I make an algebra mistake, it's okay. You can figure it out by yourself. I'm not trying to teach anyone algebra here. 10x over 3 minus 10 over 3 10x looks correct to me. I don't know. F derivative x is from here 1 over 3 times, let's start with the first term, 3 tan squared x multiplied with, it's not inside, multiplied with 1 plus tan squared x plus tan over 3 multiplied with 1 plus tan squared x. Let's continue from here. Plus 1 over 3 tan x, 1 over 3. 1 over tan x is equal to 1 over sine x over cosine x, which is equal to cosine x over sine x, which is equal to cotangent x. Differentiate this. This will be a minus 1 plus cotangent squared x. Which part are we here? Minus 1 plus tan squared x over 3. I feel like we made a mistake, but I hope we did not. Minus, it will be a minus again because this will be cotangent x. 10 over 3 multiplied with 1 plus cotangent square x. And last term is minus 1 over 3. Again, tan x, which will be cotangent x, which will make this a plus. 1 plus cotangent squared x. Yeah, I should have checked the problems before picking them. I mean, I don't think they will ask anyone a problem like that is this long. Like, yeah, it's not hard, I know, but it just takes time for no reason. Let's continue. We had more problems, right? Fx is equal to, again, differentiating this. F derivative x, derivative of division. Differentiating the numerator. 1 cosine x. Cosine x differentiated as a sine minus sine x, so negative x sine, and there's minus sine x. Differentiated the first term here. Now we multiply this with the denominator, x cosine x plus cosine x minus, oh my god, this minus, I'm going to continue from here. Now we differentiate the denominator, cosine x plus minus, because differentiating the cosine will give us negative, sine x multiplied with x plus cosine x again. I'm starting to confuse what am I even doing, right? I differentiated this part, now we differentiate this part, minus sine x again. We differentiated this term, now we differentiated this term, multiplied with the numerator x cosine x minus sine x. This is over x cosine x plus cosine x squared. Of course, I'm not gonna go in any algebra other than this. Was that the last problem? No, it wasn't. Is this, I hope this is the last problem, because seeing these problems absurdly long kind of frustrates me. F derivative x, 1 over 3 tan cubed x minus 10x plus x. Alright, composite form again. We will start with the cube, 3 tangent squared x minus, no, we did not differentiate the inside of it. Now, cancel these out too. I can multiply with the differentiate of indifferentiate. Oh my god, differentiate 10x 1 plus tan squared x. I can't even speak anymore, to be honest. Minus differentiating 10x 1 plus tan squared x plus 1. Again, algebra. I will leave it to you if you want to continue, but I think even in exams, they don't want you to continue further this, because the point is not doing the algebra. The point is showing that you can differentiate and apply the rules. We don't have any other problem. That's it.